Hello everyone, welcome to IKSHAK Academy. The chapter is carbon and its compound. Okay, in this chapter, now I am going to teach you that how can you name a carbon compound. So first of all, let us know about the suffix and prefixes which are used in the nomenclature of carbon compounds. First of all, there is a prefix halo group, that is bromomethane, chloropentane. Okay, so here bromomethane. That means here is methyl group, methane, that is alkane group, and bromo belongs to the halo group. Okay, this is from halo group. Here bromo, this halo group is used in the previous, the name of the previous, that is alkane group. Here, okay, here methane, and before we writing methane, we have to write first the name of the halo group, that is bromo. Bromo means bromine is attached to methane group. Okay, so this is known as the prefix. Okay, let us consider ethyl alcohol. Here, ethyl alcohol. Ethane group is present, ethyl, and alcohol. Alcohol is the either suffix. This is not the prefix because alcohol, this functional group is written after the name of ethane. Alkane group, ethane, ethyl alcohol. Okay, that means here this is the functional group, that is alcohol. Alcohol functional to single bond OH. This is the functional group. Okay, and in case this is the suffix. Okay, so now this here is prefix, here is suffix. Now I am going to teach you that how can you name an organic compound and a carbon compound by using the functional groups. Here are some functional groups. You have to remember these things. First, halo group. Okay, halo group means single bond chloro, single bond bromo. Okay, these are the halo groups which are using the prefix. Then alcohol group, single bond OH, alcohol, and for this group we have to use suffix, that is OL, all. Then aldehyde group, these are the name of the functional groups, that is single C, single bond, double bond O, and single bond H. Okay, carbon, here double bond O and single bond hydrogen is present, and here is also suffix, that is al. Okay, then after this ketone, C double bond O. Okay, also suffix ONE. Then carboxylic acid, that is C double bond O, single bond OH. Here is also suffix, that is oic acid. Okay, so these are the functional groups which you have to remember. These are the for only standard 10th, but for the higher class, for the students who are studying in the higher class, there are so many functional groups. Okay, so here suffix only in this case. In this case, prefix is used. Okay, I have already told you in the example, that is bromomethane. After this, there is alkane. Alkane group you have already studied about that. Alkane. In case of alkane, there is C single bond C. In between carbon, there is a single bond, that is alkane group. In case of alkene, and the general formula is CnH2n plus 2. This is the general formula. Okay. In case of alkene group, C double bond C. That means in between two carbon atoms, there is a double bond is present. So here the general formula is CnH2n. Okay. And alkyne. Alkyne group, that is C triple bond C. CnH2n minus 2. When you are naming a carbon compound, let us consider hexane. Hexane, ANE. Okay, ANE means this is in alkane group. Okay, so alkane means here is ANE, alkene means here is ENE, and here is YNE. When there is a single bond, then any, that is prefix or suffix. Here you have to use as suffix, and when there is a double bond between carbon and carbon, then you have to use ene as a suffix, and when there is a triple bond between carbon and carbon compounds, you have to use yne as a suffix. Hexane, this is alkane group. Hexene, ene, this is the alkene group, and hexyne, yne. So here is the alkyne group. Okay, so then there is another thing you have already remembered these things from the beginning of this chapter, that is when number of carbon atoms, as per the number of carbon atoms, what will be the name of that carbon compound, that is when number of carbon atoms, when this is 1, that is known as meth. You have already known about this. When 2, that is known as eth. When 3, prop. When number of carbon 4, then that is bute. Okay, then 5, paint, and for 6, that is hex. For 7, that is hept. For 8, that is opt. For 9, that is non, and for 10, that is dec. Okay, you have to remember these things. These are the most important things you have to remember. Okay, functional group as well as alkane, alkene, alkyne, where single bond, double bond, triple bond, and the number of carbon atoms, that is methyl propute. So now before, when you are going to name a carbon compound, then you have to remember these things. Okay, now we are going to name a carbon compound using suffix, prefixes, and the functional group methyl propute, alkane, alkyne, alkene, with some of the examples. Okay, let's watch carefully. Let us consider there is a carbon compound that is known as propane. Here is chloropropane. That means from this name, you can find that there is a chlorine group. Chloro, that is halo group. Okay, and propane, this is here is alkane group. So propane means, I have already told you that pro means there are 3 numbers of carbon atom are present, 3 for pro. So propane, what is the formula for propane? CnH2n plus 2. This is the alkane group. So propane's carbon, 3 carbons are present. So 3 C3H, 3 to the 6 plus 2 H, C3H8. This is the propane. Okay, chloropropane. That means we have to add or join chlorine group as the halo group in the propane. Okay, that is the functional group. So here 3 carbon atoms for propane, and here hydrogen is present. You have already known that carbon has a valency of 4. That 4 carbon can that is a property that is known as catenation property. So carbon carbon does not release any carbon atom, release any electron, or gain any electron. It can make a bond with other element as a sharing pairing of electrons. That bond is known as covalent bond. Okay, so always carbon atoms make 4 bonds with another carbon atoms or other elements. Okay, so here carbon, that means here is single 1, 2, 3 and 4. Okay, this carbon is stable. Okay, here, right, 1, 2, 3, 4. So this carbon is also stable. Here hydrogen, and in case of chloropropane, here is a halo group chlorine is present. You can write this chlorine here, and you can also write this chlorine also here. You can, okay. Then chlorine. In case of propane, we have to write a hydrogen atom here, but in case of chloropropane, we have to write the functional group, that is chloro here, chloro. And this C3H8 is the propane. We remove 1 hydrogen and replace that place with chlorine. That is, this is known as chloropropane. When you are doing this type of example, when you are diagrammatic representation of a carbon compound as the bond structure, or this is the skeletal structure of the chloropropane, then you have to remember one thing, or don't forget to count the number of bonds. Okay, if I miss a hydrogen here, then this will be wrong, because you have to count always, that is one carbon atom makes 4 bonds with other. That here 1, 2, 3, 4. Don't forget to count the number of bonds. Okay, here is the chloropropane. Next example is, let us consider pentanol. Okay, pentanol. So here is pent means carbon. There are 5 carbon atoms are present, and ol suffix is ol. Ol suffix is used for the alcohol group. Okay, there is a functional group used that is known as alcohol group, that is pentane. Just remove plus ol, that is pentanol. Pentanol. Okay, just E, replace the E with ol, pentanol. So pentane is, there are 5 carbon atoms, 1 2 3 4 5 carbon atoms, and here just write hydrogen. Okay, alcohol, the functional group of alcohol is single bond OH. This is the functional group of alcohol. Okay, single bond OH. Here we have to put that single bond OH. So here 1 2 3 4. This is stable. 1 2 3 4 stable. 1 2 3 4. 1 2 3 4. But here 1 2. So we have to put hydrogen. 2 hydrogen here. So let us just count yourself that all the carbons are stable or not. This is the structural. This is the structure, or this is the skeletal structure or bond structure of pentanol. Okay. Then hexanal. Hexanal. So here hexane is present. Hexane. That means number of carbon atoms is 6. Hex for number of carbon atoms is 6, and suffix is present Al. Al is the suffix for aldehyde group. Functional group is your aldehyde group. Okay, aldehyde, and the functional group is single bond C double bond O single bond OH. No, single bond H. This is, so when we write single bond OH, then it will be carboxylic acid group. Okay, this is the aldehyde group. So hexane, that means carbon, 6 carbon atoms are there present here. 1 2 3 4 5 6. 3 4 5 6. Same trick is used. Okay, here single bond hydrogen and double bond oxygen is present. That is here double bond oxygen and single bond hydrogen is present. Okay, 1 2 3 4 5. Here everything is right, but aldehyde group is C double bond O single bond H. If you write C double bond O single bond OH, then it will be carboxylic acid group. There are two groups. One is aldehyde group, another is carboxylic acid group, another is alcohol group. Most of the students make wrong, and there are so many errors are found in between these aldehyde, alcohol, and then carboxylic acid. This problem arises. So here the aldehyde group is H. Okay. If we write here single bond OH, then it will be carboxylic acid. So this is the complete, that is known as hexanal. Okay, alcohol Al aldehyde group. Okay, this is hexanal. Then another example for another functional group, that is pentanone. Pentanone or pentanon, all are right. Pent means carbon atom. Here is 5 carbon atoms. 1 2 3 4 5 carbon atoms. There is ONE. ONE, the functional group is ketone. Ketone is C double bond O. Okay, here is single bond. Okay, pent means carbon, number of carbon atoms. Number of carbon atoms is 5. Pent for 5. So ketone group, let us consider. Write hydrogen. Okay, the examples which are already given, to you, that is we are writing here double bond O. So here is 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Here is 1 2 3. 3 bonds are present. So we have to make a bond with another bond. Well, here is hydrogen. Okay. So we have already known that ketone group is C single bond O. Here is also C single bond O is written, but in this case, just found in this case what happened. If we write hydrogen here, then this is a functional group of aldehyde. C double bond O single bond H. Here already I have written already in this example. So we cannot write hydrogen here, we cannot place double bond O oxygen in the last carbon atom or in the first carbon atom. If we write the double bond O, we place the double bond oxygen in the first or last carbon atom, then that will be another functional group, that is aldehyde. Most of the students making this type of wrong things. So just carefully when you are doing this type of things, then we cannot place the double bond of oxygen in this place. Okay, so we can write H. So we cannot write double bond of oxygen here or here. So we can write double bond of oxygen here. We can write here, we can write here, we can write here. Okay. Then just count the bond. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. So this is wrong. So carbon, in case of carbon can also make for 5 bond structure with other elements only 4 bond structure. But here when we place double bond of oxygen, then this is wrong. 1, 2, 3, 4, 5. So this will be wrong. So we have to remove and the single bond of hydrogen from here. So just count 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right? 1, 2, 3, 4. 1, 2, 3, 4. So this is the perfect structure of pentanone. Okay. Then another type of functional group. Let us consider butanoic acid. Okay. Here butanoic acid. But means number of carbon atoms equals to 4. But means 4. And oic acid. Here is a functional group present, that is oic acid. Oic acid functional group name is carboxylic acid. It's carboxylic acid. You have to remember these things. You have to remember the name of the functional group. Okay, carboxylic acid, that means C double bond O single bond OH. That is COOH. Okay, and the suffix is oic acid. I have already told you. Butanoic acid, that means there are 4 carbon atoms are present. 1, 2, 3, 4. 4 carbon atoms. Oic acid, here hydrogen. Okay, C double bond O single bond OH. Just count here 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Perfect. This is known as butanoic acid. Clear? So these are the basic functional groups, and after that there are other 3 functional groups, and those exist in between the carbon and carbon. Here carbon between hydroxylic acid, carbon between oxygen, but those functional groups, that is alkane C double bond O, alkene C double bond C, alkyne, that is T triple bond C. Okay, let us consider ethene group or hexene. Let us consider hexene. Hex means number of carbon atoms is equal to 6, and ene group is present, that is C double bond with C. There is a double bond is present. So hexene hexene carbon 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6. Here C double bond C. That means you can place the double bond here. Okay, let us consider here is the double bond. So place hydrogen. 1, 2, 3, 4. Right? Then here 1, 2, 3, 4. 1, 2, 3, 4. Stable. Then 1, 2, 3, 4. 1, 2, 3, 4. Right? Here it is stable. 1, 2, 3, 4. Stable. 1, 2, 3, 4. Stable. 1, 2, 3, 4. Stable. So this is known as hexene. So as for this alkyne group, hexyne or butane, let us consider pentane. Yne, pent means carbon is 5. 1, 2, 3, 4, 5. 5. Here pentine, Yne means there is a C triple bond C. C triple bond C means that means C triple bond C. Here place the triple bond. So hydrogen. 1, 2, 3, 4. Here 1, 2, 3, 4. This is stable. 1, 2, 3, 4. This carbon is also stable. Then place hydrogen here. 1, 2, 3, 4. Now count the bonds 1, 2, 3, 4. Right, this carbon stable 1, 2, 3, 4. This stable 1, 2, 3, 4. Stable 1, 2, 3, 4. This carbon stable 1, 2, 3, 4. This carbon stable. So this is known as pentyne. Okay, I have already told you that which things you have to remember, and when you are doing the naming of these things, or when you are doing presenting this structure or bonding structure of these carbon compounds, then be careful counting the bonds. Okay, and be careful about the functional groups, suffixes and prefixes. Thank you very much.